What I'm saying, I need to display data from multiple tables. Please understand it. Now I am as a student trying to understand the same thing. I need to display data from multiple tables. That's my requirement. So what will be my approach? If I check, I know how to write, till now I know how to write select queries for one table only. Am I correct? Am I correct, Prasanna?
Yeah, yeah.
So till now I know how to write a select queries, how to write a select queries for one table. So here we need to find data from multiple tables. Our first thing came into picture was for all entries. For all entries. What it is saying, it will bring the data from the dependent table based on data in the header table. This is the definition of it. It will bring the data from the dependent table based on the data in the header table. So we will follow all those approach. We will have what should I say? Structure declaration, structure and internal table creation. And please understand this thing. Final output should be in one internal table only. One internal table only. That is also the thing you need to do. So here we have two tables. Let's say I have Mara and MAKT table. Mara and MAKT. Material master header and material master item. Material description. Mara and MAKT. MAKT. Okay. Both have the common maintainer here. So I will declare the structure for Mara first. I will go there and I will declare the structure for Mara. So begin of ty Mara, and I will be having fields here, maintainer, type data element. Where is Mara table? This one. I will be having some more fields here. So let's say MTART, material type its data element is also MTART. Yeah. MBRSH, industry sector, type industry sector data element. Suppose I am having three columns. So TY Mara. Then I will have MAKT. So types begin of TY MAKT. This is my MAKT. Here I will having maintainer field. So maintainer type data element maintainer. Language key SPRAS type data element. And MAKTX material description. Material description type MAKTX. Three fields I am selecting from this one also. Okay. Three fields. Now I know that I need to finally store the data in one internal table only. So I will need a final structure also. I will name this final. Begin of ty underscore final. And this final structure will consist of all the columns. So all the columns, maintainer we have already taken. So I will take the rest two columns. Total it has become 5 and I will end it. So end of ty underscore final. Okay. Then I will be having here internal tables for everyone. So LT Mara first, type table of TY underscore Mara, LS Mara, type TY underscore Mara. Then LT MAKT, type table of TY underscore MAKT and LS MAKT, type TY underscore MAKT. Yeah. Finally, LT final, type table of TY final and LS final, type TY final. This is the internal table and work area declaration. I will go for step 2. Step 2 is taking input. So I'll take input data LV Matner. Here is the common. So Matner, type data element and I will declare the select option. So select options as Matner for LV Matner. Okay, I will activate it. I will also pass a wonderful name here, select some text, and I will write here material number so that my end user can understand it. They will never understand this as Matner as it is a technical name. So I am giving a meaningful name for them here. Inside the code, it will still be as Matner, but for the user, it has become material number. Yeah. Step 3 is writing the logic. Step 3, write the logic. So first I will write the logic for header table. So select Matner, then MTART and MBRSH. So MTART, MBRSH from Mara table into table LT Mara, where Matner in as Matner. Yeah, I will check for the syntax. This is the data bringing into header table, and storing it into header internal table. Now for all entries is coming into picture. What for all entries is saying? It is used to bring the data from dependent table. So what we will do, we will first check whether our header internal table has data or not. And how we will check? We will check by using this one. If LT Mara is not initial, if it is not initial, if it is not empty, then and only then we will bring the data from item. If header internal table is not empty. Now I will bring the data from item. So select Matnar, SPRAS, MAKTX, these three fields from item table, Matnar, SPRAS and MAKTX. From MAKT table into table LT MAKT for all entries in LT Mara, where material number is equal to LT Mara Matnar, header only. That's the syntax. Same thing will be applied everywhere. Here, this thing, common one. It will be applied everywhere. So now we have the data in header and in item internal tables. We can check the breakpoint here. We can put the breakpoint and we can check, execute. Suppose I have having some input of material number. I will execute it. I will go to desktop 3 and I will check both the internal table. LT Mara 9 records, LT MAKT 18 records. So I have both the thing here. Now what I have the data in both the internal table. I will go for step 4. We need to store the data in the final internal table. Final internal table. How will you store it? So I showed a step. Step is loop on the item internal table, and inside the loop read the header. Why should we do this? Because our item can have multiple records. Header will always have only one record. We know this. So I can directly apply here loop at lt makt is my item in this case into ls makt and loop. And inside it we are required to read the header. So read table lt mara into ls mara with common key. So with key Matner is common. Matner is equal to this LSMAKT. Only for them I want to read LSMAKT Matner. And we also know every time we apply the read statement, we are required to go for size sub RC check. So if size sub RC equals to 0 and if, yeah, now you can simply store the data into the final one. So ls final, let's go to MAKT. What are the columns here? MAKT, SPRAS and MAKTX. Okay. So SPRAS is equal to LS MAKT, SPRAS and LS final MAKTX is equal to LS MAKT MAKTX. Yeah. Similarly, we will transfer the internal table Mara in also into final. So here it will be LS final Matner is equal to LS Mara Matner, LS final. Next one was MTART and MBRSH. Okay. So MTART is equal to LS Mara MTART and LS final MBRSH is equal to LS Mara MBRSH. And once all the columns are transferred, I will finally append it just before the loop ending. Append LS final to LT final and clear the work area. So clear LS final. That's the approach. That's the approach. Finally display it. So step 5, display the output. So I will loop on final now, loop at LT final into LS final and loop, and I'll go for write statement here. So write LS final, Matner is the first column, LS final, MBRSH, LS final, uh, MTART, LS final, SPRAS, and LS final, MAKTX. All these 5 columns. Let's check for syntax error. No error. Activate it. Execute. Pass the input and execute. See, Prasanna, are you okay now?
Yeah, Amrit. It's
You asked for move corresponding, correct? So let me show
yeah.
that also. Wait. Please come. Let me use the same thing for it. What is the meaning of move corresponding? This MAKT has some records. So instead of writing, suppose in this case, we have only 2 records. So it was easier for me to write each column and transfer it. But when we have like 10, 15, 20, 30 columns, it will become really difficult. So move corresponding is like a shortcut. We can just go for it. Move corresponding LSMAKT to LS final. So what are the columns from LSMAKT? They will be transferred here into LS final. Same thing we can do this for Mara also. So move corresponding LS Mara to LS final. That's the thing. It is a easier approach. One line. It doesn't matter how many columns are there. All the corresponding columns will be transferred. Now let's check this. Same input, same output.
Yeah, Amrit.
So guys, if you are not watching the recordings, if you are not practicing, I am really sorry. You will forget everything. That's why I'm requesting on a daily basis. Please do the practice. That's why you are getting the recordings. Was it the same assignment? Yes or no?
Yeah, Amrit.
Everyone. I'm not getting any response. I said everyone.
Yep.
Please understand this is not for my better. It's only for you. You need to practice it. Okay? That's the one concept to bring the data from your item table by using for all entries. Next is the easier approach, joins. Yeah. So when we are working on we are working on HANA DB, we can directly implement joins. Implement joins. We can directly implement joins. Directly implement joins here. Yeah. So what is the definition of a joins? Joins are used to bring the data from multiple tables based on common columns using a single select query. See the benefit of it. No complex situation like this. But again, you need to understand each and every aspect. No complex situation like this. Only a single select query. You have all the records. Only a single select query and you will have all the records. Yeah, you will have all the records. See this? I will follow the same approach. I will go to SE38 and I will create joins. Joins, create joins in ABAP. Type executable, package, and transport request. Let's take the same requirement. So now I'm not going to have all these things. I will have step one, structure and internal table creation. Step one. And instead of creating both the header and item table, I will directly create the final structure. That's the beauty of join. No need for all those. Directly go for final structure. Directly final internal table and work area. So data, LT final, type table of TY final, and LS final type TY final. That's the beauty of it. That's the beauty of it. Yeah. Yeah. Okay. Let's see this. So next step was to take the input. So it will be same. Bring it. I'm requesting you all do not do the copy paste. You need to write it. Write it as much time as possible. Yeah. Because when you write the code, Your fingertips will remember the code. This is step 2. Step 3, write the logic. Let's see the magic, how things are changing here. Now select queries. So we have two tables. One is Mara, another is MAKT. What are the columns from Mara? Three columns from Mara, two columns from MAKT. So this is how you are going to implement Mara tilde operator. Please see everyone, tilde operator. This tilde operator you are going to see just below ESC or just above tab. Use shift and that you will see it will be implemented. Tilde operator. Then columns Mara, another one MTART. So MTART, Mara, MBRSH. So MBRSH. Then the next set of tables. So MAKT, column is SPRAS. So SPRAS, MAKT, MAKTX. So MAKTX. Two tables, all the columns, whatever we need. Then from Mara table, and now we will perform join. So inner join, we are combining these two tables. Inner join Mara, inner join MAKT. These two tables Mara and MAKT. On what are the common columns between them? So Mara Matner is equal to MAKT Matner. Only this data will come here. MAKT Matner is equal to Mara Matner. Yeah. Okay. Then I will store it into table LT final where Mara Matner in our select option. So S Matner. See this single select query. Check for error. No error. See this single select query from Mara inner join MAKT on Mara Matner is equal to MAKT Matner. MAKT Matner. Now I can directly display it. So this time step 4, display. Display same loop here. That one, last one. Bring it and paste it. Yeah. See how simple it has become. Same thing. So two approaches are there, but you need to understand all of them. But you need to understand all of them. Yeah, you need to go through all of these things. Okay, let's activate it. I will put here a debugger breakpoint. Execute. I will pass material numbers and I will do the execution of code. Okay. So desktop 3 is there. And now I will press F6. What is the size of RC guys here? What is the size of RC?
0.
0. What does size of RC 0 means? This above
Output.
operation has been executed successfully. So if I check LT final, how many records we are getting? Are we getting all the columns? Yes or no? Check the output of both these things now. Check the output of both these things. Say this. Now is it okay? Prasanna, are you getting?
Yeah, a bit.
Everyone, I'm asking it again and again. Are you all getting this? Please be interactive. Ask even meaningless question. I don't have any problem. But if you are learning, I will be happy. So this is for two tables. Suppose I have three tables here. Then suppose I want to bring the data from VBAP also. VBAP. So suppose I am taking here Posner and Veblen also. Two columns I am selecting. So here I will just need to add two columns Veblen, type its data element, Veblen VA, and item number, Posner type, Posner VA. So another inner join will be implemented inside the select query. So after one join, another join. So inner join, this time it will be VBAP on MAKT Matnar is equal to VBAP Matnar. But please ensure there must be a common column. Inside VBAP, we have a Matnar field. So that's why I am able to implement it. Now here also I will call it. So ls final Veblen and ls final Posner. Let's check for error. No error. Activate it and I will execute the code. So I will pass the input here. Okay, this one is not fetching any value. Let's pass another input, another material number. See, so it will bring only the common values. So you will have to check in this situation for all these three tables, Mara, MAKT and VBAP, what are the common material numbers? Only those data will be brought up. Only those data will be fetched. So if you want to check what are all the common columns in between them, you can directly check it after removing this where condition. Let's say this execute, directly execute. These are all the common columns between these three tables for material numbers. For material numbers. So two ways are there to bring the data from dependent tables, uh, joins and for all entries.